Hi to everyone. In this video, I would like to explain about properties of cross-correlation function. Cross-correlation function is defined as for the case of two random process x of t as well as y of t. The proofs for the case of properties of cross-correlation function are, the first one is rxy of minus tau is equal to ryx of tau. This property describes the symmetric property of cross-correlation function. To prove this, let us take RHS. R xy of tau is equal to, from the definition of cross-correlation function, it is equal to the expected value of x of t into y of t plus tau. Now, put tau is equal to minus tau. Therefore, rxy of minus tau is equal to e of x of t into y of t. Instead of plus tau, now replace with minus tau. This is y of t minus tau. Now, let us consider u is equal to t minus tau. From this, t is equal to u plus tau. Substituting these two in this equation, we are obtaining rxy of minus tau is equal to e of x of, now instead of t, substitute as u plus tau. That's why u plus tau into y of, instead of t minus tau, substitute as u, y of u. Now, in the next step, rearranging x and y terms here, if you see here, this is e of y of u into x of u plus tau. Now, you can observe that this is the definition of cross-correlation function. That's why this is nothing but equal to r. The cross-correlation function, first here you have defined the y of t. That's why first we let as y. Next we are writing as x. That's why ryx of tau. Here you can observe that rxy of tau is equal to e of x of t into y of t plus tau. First we are having x, that's why here x. Next one is y, that's why here y of t plus tau. But here y and x are interchanged here, that's why it is nothing but ryx of tau. So, therefore, you can observe that rxy of minus tau is equal to ryx of tau. That means, when you have replaced tau with minus tau, this corresponding random process x of t as well as y of t are interchanged. But there is no any minus here, that's why it is going to satisfy the symmetrical property, but not the even symmetry. Suppose these two are not interchanged, then you can tell that those are satisfying the even symmetry property. But the cross-correlation function is satisfying the only the symmetry property. Next one is, we have to prove that rxy of tau less than or equal to square root of rxx of 0 into ryy of 0. To prove this one, we have to take the one of the positive quantity, that is x of t by square root of rxx of 0 plus or minus y of t by square root of ryy of 0 whole square. It is always greater than or equal to 0. Something positive quantity, that means something whole square is nothing but equal to the positive quantity is always greater than or equal to 0. Now, apply expected value on both sides. That is E of x of t by square root of r x x of 0 plus or minus y of t by square root of r y y of 0 whole square is greater than or equal to e of 0. In the next step, use the formula a plus b whole square. Therefore, it is equal to e of, this is nothing but a, for this whole square is nothing but x square of t, square root of r x of 0 whole square is nothing but r x x of 0 plus this is nothing but b, for that whole square is y square of t by square root of r y y of 0 whole square is r y y of 0 plus or minus 2ab term is there. 2 into a is this one, b is this one, then writing here x of t into y of t by square root of r x x of 0 into r y y of 0. This is greater than or equal to e of 0. 0 is a constant, expected value of a constant is constant itself. That's why its value is nothing but equal to 0. Now, apply expected value to every term present in the whole bracket. We know that e of x plus y is equal to e of x plus e of y. Using that formula, this can be simplified as e of x square of t by r x x of 0 plus e of y square of t by r y y of 0 plus or minus e of 2 into x of t into y of t by square root of r x x of 0 into r y y of 0. This is greater than or equal to 0. Now, you can use the formula here. E of kx is equal to k into e of x, where k is a constant. Now, here r x x of 0, r y y of 0, this 2 by square root of this entire thing, all these are constants. Then applying that respective formula, you will get as simply e of x square of t by r x x of 0 plus e of y square of t by r y y of 0 plus or minus 2 is a constant, get out the expected value, 2 into e of x of t into y of t whole divided by square root of r x x of 0 into r y y of 0. This is greater than or equal to 0. Now, here you can observe that from the properties of autocorrelation function as well as the cross correlation function, you can see here e of x square of t is nothing but r x x of 0. That's why substituting here r x x of 0 by r x x of 0. E of y square of t is nothing but r y y of 0. R y y of 0 by r y y of 0 plus or minus, this is 2 into, this is the definition of cross correlation function. That means this is simply r x y of tau whole divided by square root of r x x of 0 into r y y of 0. In the next step, you can observe that r x of 0 by r x of 0 is nothing but 1. This is also both cancelled, is nothing but equal to 1. So, thus we can written as 1 plus 1 plus you are having 2 into r xy of tau by square root of r xx of 0 into r yy of 0. This entire is greater than or equal to 0. Here we are having plus or minus. 1 plus 1 is nothing but equal to 2. So, 2 plus or minus 2 into r xy of tau whole divided by square root of r xx of 0 into r yy of 0. This entire is greater than or equal to 0. Now, you can take 2s common here. That is why this is 2 into 1 plus or minus r xy of tau whole divided by square root of r xx of 0 into r yy of 0 greater than or equal to 0. Now, this 2 will go that side. Then the next step it is simplified as 1 plus or minus r xy of tau divided by square root of r xx of 0 into r yy of 0 greater than or equal to 0. To simplify further, you can observe that I will write 1 here. This is greater than or equal to, this entire term will go to the RHS side. Because plus or minus is there, then that will become as mod of r xy of tau by square root of r xx of 0 into r yy of 0. Now, interchanging these two, the greater than will become as less than. Therefore, r xy of tau divided by square root of r xx of 0 into r yy of 0 is less than or equal to 1. The last step is r xy of tau, which is nothing but mod we are having. That is why mod r xy of tau is less than or equal to square root of r xx of 0 into r yy of 0. That is why the mod value of autocorrelation function of x of t and y of t, it is bounded with the geometric mean of the autocorrelation functions of x of t and y of t at the origin. So, this is nothing but the geometric mean. Similarly, you can go for the case of arithmetic mean condition also. Geometric mean is always less than or equal to the arithmetic mean. That is why from this you can write one more statement, that is mod r xy of tau is less than or equal to arithmetic mean of these two. That means 1 by 2 into r xx of 0 plus r yy of 0. In this property, the cross correlation function is bounded with two values, that means geometric mean as well as the arithmetic mean. Coming to the next property, suppose if you have defined the two random process x of t and y of t, those two are statistically independent and those two are WSS, that means wide sense stationary. In that case, r xy of tau is equal to e of x into e of y. This is the one more property of the cross correlation function. Now, we will prove this property. Let us define the cross correlation function of x of t and y of t given as r xy of tau is equal to e of x of t into y of t plus tau. This is a basic definition of cross correlation function. For the case of WSS process, its corresponding expected value is nothing but the having the constant mean values. And for the case of statistically independent random processes, the combination of the expected value of x of t and y of t is equal to the product of individual expected values. That's why this can be represented as E of x of t into E of y of t plus tau. This is because of statistically independent. And for WSS, this is nothing but simply equal to E of x and this is equal to E of y. Therefore, we have proved that the cross correlation function Rxy of tau is equal to simply E of x into E of y, or otherwise you can write as x bar into y bar. So, these are the properties of cross correlation function. Finally, you can see that one of the main property of the cross correlation function is it is going to satisfy the symmetry property but not even symmetry. And the cross correlation function is bounded with two values, that is, one is a geometric mean of autocorrelation functions of two random process x of t and y of t at the origin, and other one is arithmetic mean of the same. And the next one is if x of t and y of t are statistically independent and as well as wide sense stationary process, then they will satisfy that Rxy of tau is equal to E of x into E of y. Thank you.